Okay, let's look at this example from September 2022, Eastern Cape Paper 2. This is now for today, for the 18th, that you're going to do for Tuesday. This is an example, and then yet again you will have one paper to do in class and one paper for homework. I'll post the answers for you as well, so that you can just check there. Okay, right, so here they threw us a little bit of a curveball. Is they did half circle, and normally we mostly work with a full circle, which is x squared plus y squared is r squared. Last year we did work with different half circles to get the circle in the other equation. I'm gonna transpose the x, if you remember from last year, né? The other format of the equation, and then I'm gonna take the square root with a positive or a negative, né? To get the equation like this. With the positive negative there, it's a full circle, and with the just a positive, it's a half circle. The top half on the positive y side, that would be the plus, and this bottom half circle is the minus root this. So here they threw us a little bit of a curveball with the half circle, but if you remember from last year, that is what we do with that. Alright, so we have here a diagram with a semicircle, a tangent line touching there at point Q, the point 2 and negative 2 root 3. Right, you have this page as well, so you can just keep it next to you when watching the video. It's going to help a lot. I will try to show it, but it's also going to be off the screen from time to time. Right, determine the equation of the semicircle. So the semicircle will be the negative part, the bottom part, né, of a circle, which is negative r squared minus x squared. That's what the equation looks like. Now I need to think, what is r, the radius? So if I look at this, I see there is 4 units that side, 4 units that side, 4 units that side. So obviously the r is 4, then r is 4, then the r squared is going to be 4 squared, which is 16 minus x squared, and that is the circle equation there. I see they gave 3 marks for that, but it's fine if you just write even just the answer. It's fine, you will get your 3 marks there. Right, then 2.1.2 says determine the gradient of OQ. Now you see what they are busy doing. They are guiding us. OQ is not drawn there, but they are guiding us towards determining the equation of the tangent. The first step that we do before we determine that is we find the gradient of the radius. So here they are helping us a little bit. So the gradient of the radius, which is OQ, is going to be, you can use still the formulas from there. There is the gradient formula, difference in y over difference in x, using the points OQ, and O is the point 0, 0. So difference in y, it's negative 2 root 3 minus 0 over difference in x, 2 minus 0. And you can type this into the calculator, and that should give you negative root 3 there. Right, negative root 3 is the gradient of OQ, if I type that into the calculator. Okay, then 2.1.3 now says, hence determine the equation of the tangent if the point P0 minus 5 is the point is a point on the tangent line. Right, so now here they also threw another curveball, is they give me another point there on the line, the point 0 minus 5 there down. That is the y-intercept. So let's just first do the method that we have been practicing, because that should work as well. Is the gradient of the tangent times the gradient of the radius should be -1. Why is that -1? Because gradients multiply to -1 when lines are perpendicular, and I know the gradient, the radius and the tangent is perpendicular. So the gradient of the tangent is going to be -1 divided by, if I transpose this, -√3. So even on my calculator, -1 divided by -√3, that gives me √3/3 positive value. So √3/3, right? And then what I would do now normally, if they didn't give me another point to work with, is I would do y is mx plus c with the m of the tangent, the gradient that I just found, the x and the y of this point of tangency there, right? The 2 is my x, and the -2√3 is my y. -2√3 is my y, plus c, and then just multiply this on the calculator. That gives me 2√3/3, and I'm going to subtract this on the other side to get the c value. The c value is then going to be -2√3 minus 2√3/3. -2√3 -2√3 minus the 2√3/3. That I just transpose this to the other side. That gives me -8√3/3. So then the equation would be y is m, which I calculated for the tangent to be √3/3, and then x plus c, which is now this -8√3/3. That is what I would do normally, right? But now the curveball that they threw to me is they gave me this point, right? So and I see this point that they used here, it doesn't actually work out like that, which it should, but okay. This is a y-intercept of the line because the x is 0, so that's where the line cuts the y-axis. And in the equation y is mx plus c, from grade 9, the m is the gradient and the c is the y-intercept. So they basically give you y is -5, right, for this specific question. So what they actually wanted you to do here, I'm just going to remove this. What they actually wanted you to do this is start by getting the gradient from the radius to the perpendicular line like we did up until now, and then you just write y is mx plus c with, they gave you a c, so you don't need to go through the substitution to calculate the c, and that's what they actually wanted you to do there. But even if they can give you that shortcut, that value that they give you should be the actual value of the y-intercept, which is not what we found here now, so that's not supposed to happen, but okay. Right, and then question 2.2 is now given x squared over 25 plus y squared over 16, and hopefully is 1. Hopefully you immediately think to yourself, ellipse. Right. So the first thing is sketch the graph in your special answer book. I'm sorry I haven't copied special answer book for you, so just in your normal book, sketch the graph, clearly indicating all the intercepts with the axis. So this is an ellipse given. If the ellipse looks like this is most in the standard equation of the ellipse, which is on your formula sheet. There underneath the x I found a squared, and underneath y I found b squared. So this is a squared, meaning the a is going to be 5, and this is the 16, the b is going to be 4. 4 squared is 16 and 5 squared is 25. In the formula there are squares there, right? So if I want to sketch this, what it would look like, the A goes with X, so the X intercepts are going to be 5 and -5, and the B goes with Y, so the B intercepts would be 4 and -4. And then I just draw a ellipse as neatly as possible through there. This is my major axis. They didn't ask, but just by the way, they asked. We'll get to the next question. This is the major axis, which is 10 units long. It's 5 and 5. And this is the minor axis, the short one, which is 4 and 4. It's 8. The major axis can be on X or on Y. It's not a rule that it has to be X or it has to be Y. The longer one of the two is the major axis, and the shorter one of the two is the minor axis. So, sorry. Then lesson 2.2.2, question 2.2.2 says determine the length of the major axis. So the major axis is then that one, and you can literally just write down 10. You don't even have to write major axis, you can just write down 10.